This video takes a look at Module 2, Lesson 8, applying the properties of operations to add and subtract rational numbers. Today, you guys are going to use the properties of operations to add and subtract rational numbers without the use of a calculator. You know you have this when you are able to accurately add and subtract positive and negative rational numbers, which include fractions, mixed numbers, and decimals. Our standard is 7 NSA 1D, which is apply properties of operations as strategies to add and subtract rational numbers. To begin lesson 8, we're going to look at an example. Specifically here, example 1, the opposite of a sum is the sum of its own opposite. So say we have the rational number 7. Okay, so I'll put a little 7 in this box. And say we also have the rational number -2. Now, both of these numbers are also integers because they are a whole number, 7, and -2 is a whole number opposite of +2. Okay, now 7 plus -2 gets 5. Okay, they are different signs, so you basically subtract, and 7 is further from 0. Now, the opposite of -5 is 5. So, in this table, we have two numbers we are adding together, 7 plus -2, we're getting 5. The opposite of that sum is -5. Now, let's look down here. The opposite of rational number, let's use -7, which is the opposite of 7. The opposite of -2, is 2. And the sum of this is -5. So if you notice here, the sum of 7 and -2 was 5, but then when you take the opposite of these numbers and add it, you get the opposite sum as well. So if I put this in words, I'll type this out, make sure you write this down. What this statement means is that if you have a sum and want to take the opposite, for example, and we're going to write it out like this, the opposite of 7 plus -2. Remember, this negative on the outside can also represent the opposite of. You can rewrite it as the sum of each addend's opposite, which is -7 plus 2. Okay? So, it's just a little pattern that happens in mathematics here, and just developing a little bit more skills for you to have in your tool bag. So if you want the opposite of this sum, right, you want the opposite of this sum, you're going to end up just adding the opposites of each of the individual numbers, and you'll end up with the opposite of the sum. Now, we're going to scroll down a little bit, and we're going to look at exercise 1. What I want you to do, whatever strategy you need, other than the use of a calculator, I want you to attempt, to find the basic answer to this question. You need to write this as one singular rational number. So we currently have 3. I need you to combine and simplify this down to 1. When you are done doing that and try your best, come up with a strategy to get there, come back, check the video, and I'll show you 2 different ways to get to the sum here. So looking at exercise 1, I'm going to show you 2 different methods. So I'm going to walk through this. Now your answer should have been 5/20 or 1/4. Now I'm going to show you one strategy to begin. So we have this expression, right? What I can do just to kick things off is, because I see I'm adding and I have subtraction here, you need common denominators with these fractions. So what I can do first is find a common denominator. And I know the least common denominator here is 20, because I have 5, 10, 15, 20, then 4, 8, 12, 16, 20. 20 is the lowest multiple for these denominators. So to get 2/5 to be 20, we have to multiply by 4/4. So then I have -2, the whole number is going to stay. And now I have 8. Make sure that's neat for you guys. So you have -2 and 8/20. Okay? Now, to get the 3, the whole number is going to stay the same. To get the 1/4 to have a denominator of 20, you would have to multiply by 5/5. So that is 5/20. And then, once again, to get that 5th to have a denominator of 20, you would need to multiply by 4/4. So that gets 12/20. All right? So I've taken the first step to make all of my fractions have common denominators. Now, next thing I'm going to do is I'm going to switch all of my mixed numbers into improper fractions so that I can then add. So you multiply the whole number times the denominator and you add the numerator. So this stays negative and it is 48/20. Just make sure you always keep the sign. If it's negative, it's going to stay negative. Just like if it's positive, it will remain positive. 3 times 20 is 60 plus 5 is 65. And then fortunately for us, this last rational number here is a fraction, not a mixed number. So it just stays the same. Now, at this point, all you need to do is use your negative number rules that we know to add and subtract the denominators. -48 plus a positive 65 is 17. They're different signs, so you subtract and you keep the sign of the number that is further from 0. 65 is further from 0 than the -48. So we have essentially 17/20, and we have this -12/20 left, or subtract 12/20, depending on how you look at it. All right. Now this is very straightforward. 17 and a -12, or 17 minus 12, that essentially means the same thing, is 5/20. And if we simplify that, that is a quarter, or 1/4. So right here is our most simplified answer. All right. So that is strategy number 1. I'm going to write in blue a different strategy. Okay. So say we are starting with this problem. Now, what I like to do is I like to get rid of subtraction, or just think of it as adding negatives. So I'm going to rewrite this, and I'm going to write it over here to get a little bit of space, because I'm going to be working out quite a few steps. So I'm going to start up here. So I'm going to write the -2 and 2/5. The 3 and 1/4 is still a plus. It's a positive. I'm adding that, so I'm okay with that. And I'm going to switch this minus 3/5 to plus a -3/5. Okay, I don't like having subtraction. I just like thinking of it as everything's addition, and you're either adding negatives or adding positives. Now, a big strength in this, you can add numbers in any order. So what I'm going to do is I'm actually going to add these two. Now, if you're asking why, the simple answer is they already have common denominators. So it's a lot easier to put those together. Now, if you have the -2 is still our mixed number, our whole number, and then you're basically adding a -2/5, because the whole number is negative, including the fractional component, not just the whole number. Everything's negative. You're adding a -2/5 and a -3/5. Okay? So this entire number, the 2/5 and the 3/5, gets the 5/5, which we're going to rewrite in a second. But I added these two fractional parts. I got 5/5, and two negatives add together, and they're going to remain negative. Now, I still have, in this case, plus the 3 1/4. That doesn't go away. It is still there. You can't just drop numbers unless you do something with them. Okay? Now, this 5/5 is an extra whole. So that makes -3 now. Plus 3 1/4. Now, if I just pay attention to these whole numbers, those whole number components are opposites, right? The -3 and the 3 are additive inverses. They're opposites. Those would get 0. So all that's left here is 1/4. Now, you just saw two different strategies. Not one is better than the other. The second method isn't better than the first simply because I showed you it second. What you need to be comfortable with is picking strategies that best suit what you understand most. And you also need to be comfortable enough to analyze that both of these are done correctly. Like if you get the problem, this student worked through the problem, here are their steps, is it correct? Or what error did they make? You have to be able to analyze that. So you have to be flexible enough to understand both and then also pick which one you're most comfortable with. For example number 2, we're going to look at mixed numbers in detail because mixed numbers aren't used super frequently in math, and you guys haven't had too much practice with them as much as maybe just regular fractions or even improper fractions. Now, 2 2/5. If we are looking at 2 2/5 on a number line or just in general, you can look at it as essentially 2 plus 2/5. That's what gets the 2 2/5, and they're kind of just shoved together as one kind of mixed number. Okay? So if we're here, you go 2 to get to 2, and then there's an extra 2/5, making up the 2 2/5. Now, the opposite of 2 2/5 is negative 2 2/5, and I'm just going to make that note down here. The opposite of 2 2/5 is negative 2 2/5. Okay? They're opposites because they're equidistant from 0. You can see down here, you go 2 to the left, and then that extra 2/5 still in the left direction. They're opposites, they're equidistant from 0. So instead of looking at 2 2/5 as one combined number, right, one mixed number, we're going to look at it as the sum of two numbers, the sum of 2 plus 2/5. We got two numbers here, two rational numbers. In the negative way, if we're looking at going in this direction, and we want to write this as a sum of two rational numbers, it is basically the idea of negative 2 plus a negative 2/5. Okay? Those two components together end up getting you the negative 2 2/5. And I'm going to make a note of that as well. So negative 2 2/5 written as the sum, right, the addition of two rational numbers is negative 2 plus negative 2/5. It's very important we understand that concept because when in a second you go and practice this idea of adding complex rational numbers, if you think of mixed numbers as purely just one compound number that sticks together and not something that can be split apart into two different rational numbers, it limits your flexibility. It limits your ability to solve problems easier rather than more difficult. So what I want you to do now, we're looking at exercise 2. I want you to rewrite each mixed number as the sum of two sign numbers. Sign numbers mean positives or negatives. So just like we wrote 2 2/5 as 2 plus 2/5, and we wrote negative 2 2/5 as negative 2 plus negative 2/5, go ahead and apply that same strategy to these three exercise 2 problems. When you are done, come back and check the video before you move down to exercise 3. For exercise 2, you see the answers you should have gotten here. Rewriting each mixed number as the sum of two signed numbers. Just keep in mind for like A and B, if the entire mixed number is negative, that makes each part, when you split it apart, negative as well. So you notice the -9 is negative, and so is the -5/8. For B, the 2 is negative, but so is the 1/2. Now for C, if the whole number is positive, then both are positive. Now I want you to look at exercise 3. What you're going to do with exercise 3 is actually work backwards. So we're going from having the sum of two signed numbers back to writing it as a mixed number. So work backwards, combine these together into one mixed number, then come back and check the video to make sure you did exercise 3 correctly. So now on your screen you can see the answer to the 3 parts of exercise 3. For A, you should have got -1 and 5/12 when you combine those together, 30 and 1/8 for part B, and -17 and 1/9 for part C. Noticed in A and C, you don't put two negatives on both the whole number and the fractional component. So just keep that in mind. It shouldn't have been -1 and then a negative again. Just one negative, if it's written as a mixed number, assumes that both parts are negative. All right, now we're at some exercise questions where it's asking you to push a little further and apply some skills to real world questions. So what I want you to do is look at exercise 4, go through, use some close reading strategies, come up with an answer. Because it is a word problem, write your answer in a complete sentence. Then when you're done, come and check the video before you move down to exercise 5. So for exercise 4, losing 10 pounds is a negative. All right, so I'm going to represent that with a -10. By winter, she gained 5 in a eighth. So that is adding, or that is a positive 5 in an eighth. Okay, so gaining here is a plus, and losing is a negative. Now, we need to represent the situation with an expression, which we already did. All right, this is an expression. And then it's asking, what is the overall change? So this is the question we need to answer. Now, I'm going to use the strategy of splitting this up. So watch what I do here. I have -10. And I'm going to split 5 and 1/8 up into 5 plus 1/8. Oops, sorry about that. Make that a little bit smaller. Now, the reason I'm doing that is now I can add these two. -10 plus 5, those are different signs, so I'm thinking I'm really subtracting, and the negative is further from 0, so that is -5 plus 1/8. Now, I have enough number sense to know -5 plus 1/8 is -4 and 7/8. Essentially, what you're doing is you're taking, I'll write this out in case you're kind of stuck, but if I can rewrite this as an improper fraction with a denominator of 8, that would be 40. 8 times 8 is 40. 1 times 8 is 8. Plus 1/8. Okay, that gets 8 in my denominator because it's going to stay the same. And a -40 plus 1 is -39. 8 goes into 39 4 times with 7 left over. So that's where I'm getting my answer of -4 and 7/8. But hopefully, like I said before I showed you this, you just have enough number sense to know, oh, if I'm at -5 and I'm adding an eighth, I'm moving to the right on a number line by 1/8. So I'm at -4 and 7/8. Now, I'm not done because it's a word problem, so I'm going to make sure I write it in a complete sentence. Mr. Mitchell's weight dropped by 4 7/8 pounds. Or you can say he lost 4 7/8 pounds. All right, so with exercise 5, this is what I was mentioning earlier about picking your own strategy, but at the same time be able to analyze correct mathematical steps. We have Jamal here who is solving this problem, and he got an answer of -1. What I need you to do is each step, there's 1, 2, 3, 4, 5, 6, 7, 8 steps. You can write right next to it. So I'll give you an example. We have step 1. And you don't even need to write step 1 if you don't want to, because you're writing it right next to it. What he did here is he realized subtracting a number is the same as adding its inverse. All right, that's what he did. We're at this problem, he switched the subtraction to adding a negative. You need to go through each step and explain what Jamal here did. Okay, all the way through. Then what you're going to do is you should come up with another way to solve this problem. Once you have analyzed Jamal's work and come up with another way to get to -1, please come back and check the video before we move on to our lesson summary and problem set. For exercise 5 here, you saw kind of my thought process. The first step, I saw that they basically switched the subtraction to addition, which was mentioned previously. Then they changed in step 2. They applied what is called the commutative property, which means you can add in any order. So Jamal here switched his order. Then, step 3, he rewrote the mixed numbers as the sum of two numbers, and then applied the commutative property again to write the fractions next to each other. Then he added the fractions and ended up getting -7/7, which is -1. Step 6, then he added together the -5 and -1 to get -6. Then he added the -6 and -3 to get -9. And then finally, -9 plus 8 gets -1. Now, another way to solve the problem, you add space down below at the bottom of your page. What you could have done is just maybe switch the 8 to have a denominator of 7, and then switch the two mixed numbers into improper fractions, and then just added straight across. Maybe you did that. Whatever strategy you used, it should be modeled on this page. You should have ended up getting to -1. Remember, our part of the goal is to develop some flexibility and have multiple strategies to attack the same problem. For the lesson summary, notice I have underlined more efficiently. The goal with this lesson was to develop additional strategies for you to add and subtract rational numbers with more efficiently. That means quicker, more accurately, or really just quicker, right? We can solve a certain problem like this multiple ways, but when we split it apart or rewrite it, these are opposites, which get 0, so that your answer is just the 3 7/10 that's left over. If we just did this problem from left to right, it would take much more time than using our properties, and then this problem only takes literally probably 3 seconds to solve. Okay? Just keep in mind also you can split apart mixed numbers into two separate parts, the whole number part and the fractional component. Okay? Keep those things in mind. Now, the problem set is going to be your chance to really make sure you are meeting the goal of the ability to add and subtract these rational numbers using whatever strategies are most efficient, all right, and best for you, making the problem easier when you look at it, it may look pretty complicated. So go through, answer these 8 problem set questions. When you're done, I will give you the answers so that you can check off your confidence with this lesson. So for 1A, B, and C, you can see the answers writing each sum as a single rational number or a mixed number. Moving down to 2, 2 was done for you. 3, you should have gotten -6 1/4 for each side. 2 was an example just so it's clear what you were supposed to do, um, which is also written up here in the directions. Number 4, you should have -4 is equal to -4. And for number 5, you should have 54 1/2 is equal to 54 1/2. If we look here, you're taking the 55 and you're adding a -1/2, so you're getting smaller by a half. That's why it's 54 1/2 and not 55 1/2. Okay. All right. Number 6. For 6, you should have agreed with this. The sum of -2 and 4 is -8, and the opposite of -8 is 8. Remember, if you're adding two numbers and you add the opposites of those numbers, the sum will also be the opposite. Number 7, you should have gotten -$4.25. So the overall change is -4.25. Number 8, you should have got -3 1/5. For number 9, which was on the next page, hopefully you didn't miss that question. I know it wasn't on the first page that I showed you. But number 9, a sum added to its opposite always equal to 0. Okay. And we have these different examples to just show that each of these end up equaling 0. Okay. So that's it for this lesson. You should be strong and confident with having a few strategies of adding rational numbers. When you see a problem, and I'm just going to go back to the lesson summary. Few